So now let's move to multiplication. So how do we multiply these? Well, again, as a reminder, remember I itself is defined to be the square root of negative 1. And that means that I squared will be negative 1, right, if we square both sides. And of course, we're dealing with complex numbers, a plus bi. So here's 5 examples. And as you sit there at home listening to me drone on here, what concept comes to mind? How do you think we should go about multiplying the complex number 5 plus I to the complex number 3 plus 2i? All right, and I'm hoping that you guys are thinking this looks a lot like FOIL. And if you are, you're exactly right. If these were a binomial to a binomial, we would FOIL it out. So that's essentially what we have here. We got 2 terms and we're multiplying it to 2 terms. So the way that we multiply complex numbers is we FOIL. So the first times the first in this case would give us 15. The outer would give us a positive 10i. The inner would give us a positive 3i. And then the last, be careful here, right? The last would be a positive 2i squared. All right, so there's the FOIL process. We can see that there's a couple of terms that are like, right? We have 2 imaginary parts that combine up real nicely. That's 13i. And then remember, what is I squared? Well, because of the definition of I, if I square both sides, I is the number that if I square it gives us negative 1. So this is 2 times negative 1. So if we clean that up, let me just show the steps. That's minus 2. 15 take away 2 is 13. So the multiplication of the complex number 5 plus I to the complex number 3 plus 2i creates a new complex number 13 plus 13i. So kind of a unique situation there, but that's how you do it. Trying to make this more difficult, notice that my notation here, I have the square root of negative 1 and the square root of negative 9. So let's just take a moment and convert them to the imaginary numbers that they are. All right, so the square root of negative 1 by definition is I. The square root of 9 is 3. Square root of negative 1 is I. So now I've got 2 complex numbers. FOILing, 4 times negative 2 is a negative 8. My outer is a positive 12i. My inner, a negative times a negative, is a positive 2i. And then again, be careful here. A negative times a negative is a negative times a positive is a negative. And then we have 3i squared. So there's my FOIL. Again, we have a couple of like terms. Those combine up to 14i. And then back here, I squared, by definition, is negative 1. So this becomes negative 8 plus 14i plus 3. Combining like terms, real parts, we end up with the complex number negative 5 plus 14. Alrighty. Next example, we have 4 minus 3i squared. So we're squaring a difference. So again, fight that urge to apply the 2 to both terms because there is no rule for squaring a difference. So what I do is I do what it means to square. I multiply something to itself. And so now FOIL, 4 times 4 gives us a 16. The outer gives us a negative 12i. The inner gives us another negative 12i. A negative times a negative is a positive. 3 times 3 is 9. I times I is I squared. And so these two combine. That's going to be basically a negative 9, right? So we have 9 times negative 1, which is basically minus 9. 16 take away 9 is 7. And there you have it. So there's our final answer for that. So this square, kind of a perfect trinomial square if you would, results in that complex number 7 minus 24i. Alrighty, and so keep on going. Here we're squaring a sum. So again, fight that urge. There's no rule for squaring a sum or raising a power to a sum. But what we do have is what it means to square something. And that means we're going to multiply something to itself. And then we basically are at FOIL. So 2 times 2 is 4. My outer is a 10i. My inner is another 10i. 5 times 5 is 25. I times I is I squared. So again, we have a couple of like terms. That is 25 times negative 1, which is essentially minus 25. And so here's my 2 like terms. We get negative 19 plus 20i as our final answer. Okay, so all solid here. Last but not least, we have a 2 minus 3i. times a 2 plus 3i. If you're remembering, we're basically looking at the difference of squares here. So I'm looking at 2 squared minus 3i squared, right, which is 4 minus 9i squared. And so this is 4 minus 9 times negative 1, which becomes 4 plus 9. And the result here is 13. Okay, and that's pretty amazing because we went from a complex number times a complex number, and we're now back in reality. So it's almost like, you know, we're in La La Land, and then when we multiply the two together, we magically see a 13. Of course, if you don't see the difference of squares, you can FOIL it out. 2 times 2 is 4. My outer is a positive 6i. My inner is a negative 6i. And my last times last is the negative 9i squared. Those cancel out, and we're left with where we're at. Okay? The other idea here, most recently, is the idea of conjugates, right? So we have the same two terms, 2 and 3i, 2 and 3i. We're subtracting and we're adding. So these guys are conjugates. And that's going to play a very important role in our next video. So there's multiplication, onwards to division.